So, you're not sure if physics is for you. Well, this might be just what you're looking for. I'm Sean Ramsey, and I wrote this college physics guide with my roommate Caleb Dowell. Our purpose was to showcase physics to high school students who are considering physics as a career path but are unsure. We are both junior level physics majors and have been in this exact spot, so we know how difficult it can be to decide. Hopefully, our booklet will help. There are 6 sections in this booklet: classical mechanics, thermodynamics, electricity and magnetism, quantum mechanics, special relativity, and how to apply these concepts. The 3 I contributed are classical mechanics, thermodynamics, and quantum mechanics, so those will be the sections I focus on. Before we look at any material, I would like to stress that the concepts presented in this booklet are very brief overviews. As you can imagine, physics has many disciplines and they're all very deep. This booklet is just to get your curiosity going and see if you're interested in the concepts. The first section here is classical mechanics. This is where you learn the foundations that you will need for any other subject in physics. You will learn about how to do math with vectors and scalars. Vectors have magnitude and direction, while scalars just have magnitude. Kinematics is the study of motion without looking at any forces. Forces in motion are where you learn about Newton's laws and how forces affect bodies and are exchanged. Momentum is a step up from that, where you study how bodies of different size collide. And finally, there is different types of and transfer of energy. The next topic is thermodynamics. A more accurate title will be thermodynamics and statistical physics, since the way you study thermo is with statistics. Thermo looks at large systems with many small elements, and since you can't find the exact nature of every element, you must give probabilities. There are 3 laws of thermodynamics. The first says energy can either be transferred through heat or work. The second law says that in nature, systems like to have the most possible entropy. Entropy is a measure of how many states a system can be in. The third says that when temperatures drop tremendously, so does entropy. The Maxwell-Boltzmann distribution statistically predicts the probability of particle speeds. And lastly, ideal and real gases are different ways to predict the behavior of gases for different situations. My last physics topic was quantum mechanics. Many of the classical topics, such as my previous 2 subjects, tend to break down when you get to a microscopic setting. So scientists had to come up with new rules to explain these microscopic systems, and quantum mechanics was born. This book covers energy levels, which are examples of quantization, where energy can't be any value, only certain values are allowed. The wave and particle properties of light, the de Broglie relationship of how particles exhibit wave-like features, and lastly there is uncertainty principle, where you can only measure certain quantum values so accurately. Once again, I would like to stress these are very brief overviews of the concepts. For length reasons, we have left out the complex math that reinforces these topics. It can be difficult, but you will have people around to help you. If you are good at math, curious, and driven, you'll do just fine.